Bismillah Rahman Rahim. Assalamu alaikum. So this is my um, sixth semester project in which I visualized um, these algorithms. I guess these are 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 shortest pathfinding algorithms given to us by our university. And this is the demonstration video. So what I'll be doing is that I'll be running this code script that I've developed. Main.py. So this was semester project developed by me and my partner Wasif Muhammad, and this is the visualization. So it's a whole grid. Um, this is the whole grid, and I'm visualizing a star pathfinding algorithm. So here is I have set up my starting point, and this is my endpoint. Okay, so the algorithm has to find this endpoint. So I can also draw these walls in between. So let's go. Let's see if our algorithm finds it. So it already knows where's the um, this endpoint is, so it will just draw the shortest path. Now what I'll be doing is that I'll be changing um, this one, and I'll be showing you this one, best first search. Okay, so yeah, start point, end point, and now this is the best first. Again, once again I'll be showing you let's close this, and then again um I'll be showing you another one. Okay, so this was the breadth first search. Let's run it. Yep, this is the breadth first. Now, yeah, there's the walls. As you can see, it's finding the path as the breadth first should do. So it's basically using its neighbors to find it. So it's the shortest path. Okay, so let's close this. Now let's just see the depth first search. Start point, end point, walls. Yeah. So this is the depth first search. As you guys can see, it's okay. So it has found the path. It has found the path, and now this is the path from the depth first. Now I can also rerun this by clicking C. Let's click C, and it has refreshed. Okay. So again. So that's how it's gonna work, and as you can see, mm, so it has skipped the final point. Okay, so it will come back again to see if it has missed something or not, and let's see if it gets us yup, it gets us the shortest path like this. Now let me just run the other ones as well. Sorry, I was planning to develop a dashboard for it as well, but to have time to develop it. Now it's UCS. As you can see, UCS is also like this. This program or this visualization is the best because even a person with no programming knowledge can learn how the algorithms actually work. So that's the main thing. From the learning perspective, it's the greatest project that we have ever done. Okay, so another thing, depth limited search. Let's see. So as you can see, this is the depth limited search found, and now, yep, and now running this algorithm. Let's close this. Okay, iterative deepening search. So this is iterative deepening search. As you can see, it is visualizing it very sweetly. So that's the iterative deepening search. Now let me just show you the bidirectional VFS. Okay, so yep, so bidirectional searching from both sides. As you can see, it's pretty much amazing. This is pretty much amazing how what a pie game can actually do. That's lit. Seriously. Um. Okay, so Dicastra. It's finding. Yup, finding. Um. So it's finding the shortest path. Yup, this is the shortest path by Dicastra. Like one amazing thing that I want to show you guys in this project is that there's a scenario if our algorithm is unable to find this search point and the grid actually finishes. There can be scenarios where I can build again all the walls against the starting point. So let's see. So this is the coolest effect that we have added. Again, this is the shaking effect. That's amazing. So that's pretty much it from the project. I hope you like the project. So I've also linked in the GitHub repo for the in the description box so you guys can try it. So that's all from my side. Take care. We'll see you guys in another video. Till then, take care. Goodbye.